Okay, hello class. I believe we're all doing well. In our previous lesson, we talked about what a computer is. We talked about data, information, the differences of data and informations. We talked about the hardware as well as a processing cycle. We talked about a little bit about the monitor. We talked about the keyboard, though we didn't go into details about the keyboard. We also spoke about um, the mouse, the types of mouse that we have, and today we are going to look a little bit inside the computer. So basically, you know what a computer is and what it can do. So we just want to go inside a computer to see what process go on in there. All right, so now looking inside a computer system, we have the system unit. We're going to talk about memory. We're going to talk about how memory is being measured. We're going to talk about input and output devices. We're going to talk about storage devices as well. So now looking into inside the machine, we have categories of hardwares. We have the processor, we have the memory, we have the input and output devices, and we have our storage devices. So basically put, when we talk of a computer's hardware devices, this is what we are talking about. We are talking about the processor, the memory, the input and output devices, and storage devices. And these are things that are inside the computer. The processor can be found inside the computer, the memory can be found inside the computer, the input and output devices are both ways, and we have our storage devices that are also both ways. But mainly, we have our storage device inside the computer that holds the operating system and all that. Okay, so now this is a physical template or layout of how the computer is. We have our monitor, which serves as our output device. We have our printer and our speakers. These are our output devices. The monitor helps display things that are happening inside the computer. The speaker gives us sound out of the computer. The printer helps us to print the things that needs to be printed out for us to have a hard copy of it. And we have our memory, our RAM, that holds data temporarily for the processor. We have our storage devices, and we'll look closely into it later on. We have our processor, we have our input devices, which is our keyboard and mouse. This is just a pictorial graphical layout of how the computer setup is like. So moving on, we are going to go a little bit in depth of the computer. Now, the procedure that transforms raw data into useful information is called processing. So processing basically talks about taking a raw data and exchanging it or going through some series of sequence that will bring it out as information that makes sense. It's called processing. And this function is divided between the computer processor and the memory. The processor is more or less like the brain behind everything in the computer, and the memory serves as a temporal storage system that helps hold data for the processor while it works. We can also explain it like the processor becomes the boss, and whilst the memory serves as the secretary. So whenever the boss needs something, the secretary have to fetch it for the boss. So we can just use that example to help explain what a processor and memory does in this context. Okay, so now the processor is also called the central processing unit, which is also known as a CPU, the central processing unit. It manages all the devices and performs the actual processing of data. So the processor does everything. The machine cannot be complete without the processor. It is the brain of the machine. So the machine cannot function properly without the processor. The processor has access to everything, checks everything, detects everything in the machine. So without a processor, nothing can actually be done when they are being done as it's been done. So the CPU consists of one or more chips attached to the computer main circuit board, which is our motherboard. Motherboard is just like a foundation where all the computer circuits have been placed on. A foundation or a ground where the computer chipsets are being stored or hosted on. Yeah, and don't forget, if you have any questions, feel free to bring them up after you finish watching the video. Be writing them down as you are watching the video. When you're done, you can easily send your question up so we can help answer them. Okay, so now we are going to talk about optical input devices. So we have the barcode reader that can read patterns of printed bars. We have the reader emits light which reflects. Basically, when we talk of the barcode reader, we are talking about this electronic device in the supermarket or shops that helps read those lines that we see at the back of products. Those ones are known as barcode. I'll show you an example of it very soon. So it reads those ones, converts those things into numbers for the computer to understand. And that is what will be displayed for the one behind the computer to see. Those ones are hidden codes that help to, they're not usually hidden, but it's coded. So we say they're somehow hidden for the computer to understand. They host, depending on the one program in it, you can have access to all the information about that particular product, or you can just have access to the prices of the product. Usually at the marketplace or the shops, they only encode the price, the name of the products, the price, and probably the manufacturer. But when you get the actual product, there's another aspect that gives you more details. If you're able to install these barcode readers or QR code reader on your phone, you'll be able to like scan any barcode product, and then you get information about it, about the website, about the product, where it's from, and then the manufacturer and everything. All these things are hidden in the barcode. So this is how the ones in the office actually looks like. And you see those lines, those black line on the product, they are the barcode. And then the light that comes out of the machine scanning it is our barcode reader. It's just reading the barcode and then transmitting or transferring every information there to the computer, and then for the computer to display it to the one operating it to see. Okay, so here we say it emits light which reflects off the barcode and into the detector, which is the device or the reader. The detector translates the code into numbers. Computers understand zeros and ones. They don't understand a lot of alphabet. All what they know is zeros and ones. So usually they transfer them to zeros and ones for it to understand, and then gives you back the information that you need. All right, so all these ones are examples of the ones that have a code embedded in them. So we have here something known as a memory. Here we are not talking about the human memory. Here the explanation, the definition says memory also consists of chips. Okay, this one just telling you what the memory does or how it looks like. Here it says it consists of a chip attached to the motherboard. We have to see how a memory looks like. Okay, we'll get there. So the function of this very memory is that it holds data temporarily for a while so the processor can also work. So it says like this: memory holds data and program instructions as the CPU works with them. The memory is called the random access memory. We have different kinds of memory, but we are specifically talking about the random access memory. It holds data temporarily while the processor works, and when it's being needed, the processor goes to the memory, takes it, and then uses those data to work. All these things happened without your knowledge, without you seeing it. They happen at the background, so you wouldn't know what is going on. All what you know is just click and you get your results. But there's a lot more that goes on behind the scene before they are being displayed. So note well that random access memory, it holds data temporarily. Now the CPU can, when we talk about the CPU, we are still talking about the processor. So it can be, where is it? The CPU can find any piece of data in RAM. So whatever information or whatever data that the processor needs, it should be able to find it in the RAM when it needs it for processing. The RAM here is volatile. And when we say it's volatile, it means it holds data only when the power is on. The moment the power goes off, those data is lost. That is the random access memory. Keep that in mind. Now, this one talks about how memory is being read. We wouldn't go into details about it, how it's being read. All right, now we're going to talk about our input and output devices. Input devices accept data and instructions from the user or from the computer. So in other words, let me just make it this way. Anything that helps you to send data to the system is an input device. Generally, the keyboard and mouse are examples of input devices. So anything that helps you to send data into the system is known as an input device. Since we are talking about computer here, we are dealing with computers here, we narrow our devices down to computer, to mouse and keyboard. These are commonly used in the area office that you go to anywhere. And these are the basic input devices that you can actually have. Output devices return processed data back to the user. So also vice versa, anything that gives you feedback or displays the things that are going on in the system becomes output devices. Generally, printer is one, monitor is one. They give you feedback, they give you information on what's going on inside, especially with the monitor displays for you to see the things going on in the system. The printer helps you get the physical hard copy of what has been processed and the information that you need so you can carry it along so you can use it for any other thing. So we have communication devices. The communication devices such as modem and network cards. Modem and network cards, okay, perform both inputs and outputs, allowing computers to share information. Yeah. Remember, if you have any questions, feel free to ask. All right, so moving on. Still on the storage devices. Storage device, okay, we're talking of inputs and output. Now we are talking about storage devices. Storage devices host not current the I beg your pardon. Storage devices holds data not currently being used by the processor. So I can relate to the patient, let's say the patient who has been treated and discharged. Just as um, the doctor or the nurse wouldn't need his or her file at that particular moment, would take the file and then keep them in a safe place, a safe room, either in the archives or in a storeroom. So that example displays or tells us that the file is not currently being needed, so it's being kept there for safekeeping and can be retrieved whenever the need arises. So the same thing applies to storage devices. So the storage devices hold data not currently being used by the CPU, and the CPU is Central Processing Unit. That's the full meaning of the CPU. So data is commonly stored on a magnetic or optical disk. Each type uses a special medium for storing data as its interface, as its surface. Well, um, the this session we are talking about how or the places where these informations are being stored. But I think beneath this slide you see a picture of it. Yeah. So a disk drive is a device that reads data from and writes data to a disk. Basically, we are talking about storage devices. So we have a hard drive, which is our internal storage devices that stores information and is able to like retrieve information as well. You can also pass the information on to the data to a different device, which could be a pen drive or a CD drive, a CD-ROM, oh yeah, a CD drive, a disk drive, or a diskette. Currently, the diskette and CD are being obsolete because of the use of cloud storage and pen drives. So we hardly hear of floppy disks. So we don't hear much about it. But the most commonly optical storage devices are CD-ROMs and DVD drives. We'll talk about those ones in details in a bit. All right, so there's a picture of your hard drives, which is seated in the computer. It is just metallic with some sort of like, okay, it looks like a series of CDs being packed and arranged with a bar across. That's a hard drive, and that is how it looks like in the system. We have our floppy drive, which currently is getting obsolete, and our CD-ROM. These are storage devices that are being used by the system. And we are going to talk about the monitor. So I would like to ask, what is a monitor? You send me the feedback, what you think a monitor is or what you know a monitor is. Okay. So the monitor is something called the visual display unit, which is a VDU, or the cathode ray tube, the CRT. The monitor displays the output of a software running on the PC and the operations you perform via the keyboard. So basically, what we are trying to say here is that the monitor displays everything going on in the system. Whatever happening in the computer, the monitor displays it for you to see. Without the monitor, you won't be able to like see anything going on in the computer. So the monitor helps you to see the things that are going on. And we have the VDU and the CRT. Well, currently those ones two are being obsolete, but basically they're all part of monitors. And these are other categories of monitors that are in the system. We have the cathode ray tube, the flat panel, the monochrome display, the color enhanced, super video. All those ones are categories of monitors that helps you to display what is going on in the system. And this one talks about how the flat panel monitor looks like. And we have the crystal display, the liquid crystal display technology. We have the passive matrix LCD uses transistors for each row and column pixels. Anyway, the flat panel, say it takes less space. We have our this the sizes. So we are talking about the sizes. So when comparing monitors, consider four features, which is the size, the resolution, the refresh rate, and the dot pitch. These ones I would have preferred we being around to see how they actually work, but I will see how best I'll help explain this in the subsequent uh, video for you to have a better understanding of them. So these are the sizes that we have in the system. So a monitor size is diagonally measured. So we don't measure it straight, we measure it in diagonal. So for for years 15 monitors, yeah, we stand so today, all right. Yeah, so now these are monitors being measured diagonally from one edge to the other edge. So this an example of a CRT monitor, the cathode ray tube. This is how it looks like. So now, what is software? What is system software? What is application software? Someone should help bring the definition of these three up in the page. Now, so basically put, the machine cannot function without these three. Well, I say without these two, system software and application software, the machine cannot operate without them. Most importantly, the machine cannot work without the system software. And when we have applications, let's go on and you have a better understanding of it. So bringing the machine to life. Let's definition here. All right. But I still need a definition from someone else, not this very definition, a different definition. Software is a set of electronic instructions that tells the computer how to do certain tasks. A set of instructions is often called a program. So the software basically they are just instructions for the computer to follow, and the instructions are also known as program. That is what we are saying, that a software is a set of electronic instructions that tells the computer how to do certain tasks. And those instructions are often known as a program. So when a computer is using a particular program, it is said to be running or executing a program. So instructions, which is a program, and the software, that is electronic instruction. So can we say software is electronic program that tells the machine what to do? I need a feedback on that. Okay. The two most common types of programs are system software and application software. Okay. So now let's see what we are trying to talk about. So when we talk of application software, we are talking about the applications that you run that is easier for you to that makes things easier for you to um, operate. If you are to take Microsoft Word for instance, which is an example of an application software, Without the Microsoft Word, you probably wouldn't be able to like type your project. Though there are other means, there are other applications that you can use, but they are all part of application software that helps you to run certain things. With a system software, it is what the computer itself run on. Without it, you can't have the application software. The system software is what the computer actually runs on for the system software to also run on. So the application software, sorry, to run on. So we have saying system software exists primarily for the computer itself to help the computer perform specific functions. One major type of system software is the operating system. All computer requires an operating system. Even your phone requires an operating system. Some are using Android phones, and Android is the operating system. Some are using I, iOS, which is Apple product. So the iOS is your operating system. Others too are using Windows Phone. So Windows is also your operating system. So without the Android operating system installed on your phone, there is no way you can use an application software like WhatsApp or Facebook. So system software is for the system itself, and application software is for the application that you're using. Okay, so moving on, the OS, which is the operating system, tells the computer how to interact with the user and its own devices. I believe this is self-explanatory. The operating system tells the computer how to interact with the user, the one typing, and then either the one typing or the one using the machine, and then the devices itself, how they should communicate. And then we have some common operating systems. We have the Windows, we have the Macintosh, we have the Unix. We have the Linux, and all those family. But basically, these are just the commonly used ones. All right. So with our application software, we have the application software tells the computer how to accomplish tasks the user requires, such as creating a document or editing a graphic image. Some important kinds of application software are we have the word processing, we have database management, we have graphics design, we have web design, we have communication program, we have entertainment and education, spreadsheet. All these ones are examples of application software. That brings us to the end of our second lesson. If you have any question, feel free to put it up in the page and let's discuss it. Thank you and have a wonderful time.